Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're going to be evaluating an integral using Green's theorem. Now, before we get started, make sure to subscribe to the channel for notifications on more math tutorials. All right, now let's take a look at our example. So our example says, evaluate the integral of the field y sine of x, 2x cosine of y, counterclockwise in the region bounded by the rectangle with vertices 0, 0, pi over 2, 0, pi over 2, pi over 2, and 0, pi over 2. So what is Green's theorem? Well, we got the formula up here, and Green's theorem says the integral over the closed curve C of f sub 1 dx plus f sub 2 dy equals the double integral over omega, which is the space inside of the closed curve, or the area of the closed curve, of the partial derivative of f sub 2 with respect to x minus the partial derivative of f sub 1 with respect to y dx dy. So let's actually draw out our closed curve to get a better understanding of this. So our region or curve is bounded by the rectangle with vertices 0, 0, pi over 2, 0, pi over 2, pi over 2, and 0, pi over 2. Also note this is counterclockwise. And again, Green's theorem says that the integral over the closed curve itself equals the double integral over omega, which is the space inside of the curve. So let's actually start to compute our double integral. The first thing that we need to find is the partial derivative of f sub 2 with respect to x minus the partial derivative of f sub 1 with respect to y. Referencing the field that we were given, the partial derivative of f2 with respect to x is 2 cosine of y minus the partial derivative of f sub 1 with respect to y equals sine of x. So now we'll plug this into our double integral. And let's start to solve this thing. First of all, I'm actually going to put in our bounds. Those will be 0 to pi over 2. Now first, integrating with respect to x, we get 2x cosine of y minus cosine of x. From 0 to pi over 2. And when we plug in those bounds, we get pi cosine of y minus 1. So now we're going to integrate again with respect to y. So we're going to find the integral of pi cosine of y minus 1. And this gives us pi times sine of y minus y. And of course, we'll plug in bounds 0 to pi over 2. When we plug in, we get pi minus pi over 2. And that gives us a final answer of pi over 2. And there you have it. Using Green's theorem, we have solved our integral. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching the numbers game.